Okay, and then let's expand this here, expand the brackets. So minus x all squared is plus x squared, plus twice the first thing times the second thing, minus 12x, plus the last thing squared, plus 4x, plus 2x, minus 12, minus 20 equals 0. I've then got 2x squared, minus 12x plus 4x plus 2x is minus 6x. 36 minus 12 minus 20 is 36, minus 32 is plus 4 equals 0. I can divide through by 2. X squared minus 3x plus 2 equals 0, which is x minus 1. X minus 2 equals 0. X equals 1, x equals 2. To get the y value, let's substitute it in that. Minus 1 plus 6, y is 5. And y equals minus 2 plus 6, y equals 4. So the line intersects circle at 1, 5 and 2, 4. That's part B done. The circle C2 has centre 10, 6 and radius R. Given that C1 and C2 touch externally, find the value of R. So, have another piece of paper. So we've got two circles. We've got C1, which I know has got a centre of minus 2, 1, and a radius of 5. So that's circle 1. I've got circle 2, I'm assuming it's bigger, I don't know that it's bigger, which has got a centre of 10, 6, but I don't know what the radius is. But what I do know is that the distance between these 2 points is going to be the distance between the 2 radiuses. So the distance between these 2 points, we use Pythagoras, so it's the square root of the difference between the x values, which is 12 squared, the difference between the y values, which is 5, and I know that that is 13. So the 2 radiuses added together is going to equal 13. So 5 plus the radius of the big circle is 13. The radius of circle 2 is 8. Number 14, we're going through them. Okay, number 15. So 10 sine squared x minus 3 sine x equals 4 cos squared x plus 1. So what I know about that is it's a quadratic of some kind. But is it quadratic in sine x or in cos x? Well, I'm going to be able to change one of these to make sine or cos. So I'm going to change that one so I have it all in sine squared. So the trig identity that I know is cos squared x plus sine squared x equals 1. So cos squared x equals 1 minus sine squared x. So 10 sine squared x minus 3 sine x equals 4 lots of 1 minus sine squared x plus 1. So 10 sine squared x minus 3 sine x equals 4 minus 4 sine squared x plus 1. So taking everything over the one side of the equal sign, I've got 14 sine squared x minus 3 sine x. 4 add 1 is 5. Taking that over, it's minus 5. Okay, so let's go 4y squared, 14y squared minus 3y minus 5 equals 0. So that's if I let y equal sine x. Factorising this, I get 2y plus 1 and 7y minus 5 equals 0. So plugging back in my sine squared is 2 or sine y plus 1, 7 sine y minus 5 equals 0. So sine, I don't know why I've said y, it was x. Sine x can equal minus a half, or sine x can equal 5/7. Pressing inverse sine gives me the principal value, not necessarily the actual value. So inverse sine of a half. 1 divided by 2, what I was doing there, 30 degrees. I haven't put in the negative. I'm going to deal with that when I look at cast. Inverse sine of 5 divided by 7 is 45.58. 45.58 degrees. So I haven't said what the answers are yet. I've just said what my principal value is. My value in the first quadrant, if that is the answer. Sine is negative. All of them are negative. Sine is negative. It's these two quadrants. So that isn't one of the answers. The angle with the horizontal is 30. So the angle for x is 180. Add 30, which is 210. And 360, take away 30, 330 degrees. Sine is positive, so it's in A and S. So yes, 45.58 is a solution. And I get this answer here by doing 180, take away my 45.58, which is 134.42 degrees. Now, if you want to check, you can go all the way back up into this, right from the start, and plug these values into both sides and check you get the right answers, the same answers. But they are correct. Okay, part B. I want to solve tan of 2x plus 30 equals root 3, giving all solutions in the range 0 to 180 degrees. Well, when I first press inverse tan, I'm going to get my principal value. I'm going to get some answers, but they might need to be in a bigger range than that because I'm looking at this. So let's upscale this. So we want to look at 2x. Double 0 is 0. Double 180 is 360. 60. But I want to look at 2x plus 30. So adding on 30, adding on 30, adding on 30, 390. So when I'm first looking for solutions, I'm looking for them in this range because by the time I take off 30, it will be in that range. And when I divide by 2, it'll give me the answers in this range. So principal value by inverse tan of root 3. Inverse tan of root 3 is 60 degrees. So cast, when is tan positive? There and there. So my first answer is there. So 2x plus 30 is 60. And then 180 add 60 is 240. Do I need to look round again? 360 plus 60 is 420. It's gone out of that range. So now to find x, take off 30. So 2x equals 30 and 210. And x is 30 divided by 2, which is 15. And 210 divided by 2, which is 105 degrees. And again, if you want to check that they're correct, you could just press tan. Let's do it for 105. Tan of 2 times 105 plus 30 equals root 3. Gives me the correct answer, and I could do it for 15 as well. But I'm very confident that they are the right answers now. Okay, a triangle. As soon as I see the triangle there, my brain's kind of thinking it's sine and cosine rule. So what have I got? 8 centimetres x plus 2, and an angle of 60. Write down and simplify an equation satisfied by x. Okay, so it's going to be sine rule if I've got a pairing. Haven't got a pairing, haven't got a pairing, haven't got a pairing. So it's cosine rule. Now cosine rule, a squared equals b squared plus c squared minus 2bc cos a. Okay. I know, the only angle I know is this one here. Okay, which happens to be b. So don't worry about a, b and c. What you need to think about is the fact that that angle, this is the opposite side. So opposite to that is x. So x squared equals 8 squared plus x plus 2 squared minus 2 times 8 times x plus 2 times cos of 60. So x squared equals 64 plus x squared plus 4x plus 4, don't forget that, minus 2 8s are 16, lots of x plus 2, what's cos of 60? Cos 60 is a half times a half. Just going to write that out again. X squared equals 64 plus x squared plus 4x plus 4. 16 times a half is 8. So it's 8 lots of that bracket, which is 8x, and it's minus 16. So half of 16 is 8. 8 times that bracket, or minus 8 times x, and minus 8 times 2. Right, well, we've got x squared on both sides there. So what have I then got? I've got 4x take away 8x is minus 4x. I'm going to take that onto this side and say 4x equals 64 plus 4 take away 16. 68 take away 16 is 52. X equals 52 divided by 4 is 13. So there's my equation in x. Here's my solution. It's now asking me to find the angle ACB, this one here. And I can now use sine rules. So let's just put what I do know. That was 60, that was 13, that's 8. I want this angle here, ACB. So because I can pair those, I can then say sine C over the opposite side, which is 8, equals sine 60 over 13. So sine C equals sine 60 over 13 times by 8. Sine C equals 4 root 3 over 13. My calculator gives me. And C equals inverse sine of that, which is 32.20 degrees. Sorry, can't see fully on there. It's number 16. 2 more questions to go. Number 17. The diagram shows a sketch of this curve. The curve intersects the x-axis at points A, B, and they tell you what point C is. Find the x-coordinates of A and B. Okay, to find the x-coordinates, on the x-axis, the y-coordinates are always 0. We're basically solving 0 equals 5x minus 4 minus x squared. So taking this onto the other side of the equal sign, so I've got positive. Don't appear to have those answers for the next one. Never mind. Positive x squared minus 5x plus 4 equals 0. 2 numbers multiply to make plus 4 and add to make minus 5 is minus 4 minus 1. So x equals 1, x equals 4. So the coordinates of A are 1, 0. The coordinates of B are 4, 0. And I was told the coordinates of C were 5, 0. So find the total area of the shaded regions. So that area there is the integral between 1 and 4 of 5x minus 4 minus x squared. And then I'm going to need to integrate between 4 and 5 of 5x minus 4 minus x squared dx. But the answer to this is going to be negative because it's below the x-axis. And I don't want to do the area of that, take away the area of this. I want to add the positive of that. Now these two lines here, modulus signs, mean the absolute value of that answer. So even though it come out as negative, you take the positive answer. Okay. So integrating this, 5x squared minus 4x minus x cubed over 3 between 1 and 4. The absolute value of, same thing, 5x squared over 2, missed that, 5x squared over 2 minus 4x minus x cubed over 3 between 4 and 5. So plugging in 4, 5 lots of 4 squared over 2 minus 4 lots of 4 minus 4 cubed over 3, take away 5 lots of 1 squared over 2 minus 4 lots of 1 minus 1 cubed over 3, add the positive value of 5 times 5 squared over 2 minus 4 times 5 minus 5 cubed over 3, take away, to write it down here, 5 times 4 squared over 2 minus 4 times 4 minus 4 cubed over 3. And it's going to be the positive value of that. So a bit at a time, I think. So 5 times 4 squared over 2 minus 4 times 4 minus 4 cubed over 3. Let's stick that all in brackets. Minus 5 times 1 squared over 2 minus 4 times 1 minus 1 cubed over 3 is 9 over 2. Now, bit of a cheat on this one because I've already got the 4 in there. I've got to do the 5. So 5 times 5 squared, no, that's not worked out right. Bracket, no, don't like that. No, it doesn't work. Start again. 5 times 5 squared over 2 minus 4 times 5 minus 5 cubed over 3, take away 5 times 4 squared over 2 minus 4 times 4 minus 4 cubed over 3 is minus 11 over 6. Sorry, it was an add there, wasn't it? So it's basically 9 over 2 and then add 11 over 6, which is 19 over 3. However, there was lots of space for me to make an error there. So what I'm actually going to do is I'm going to use my integral sign here to calculate the definite integrals. So I'm doing the definite integral of 5 x minus 4 minus x squared between 1 and 4, and I'll get that, it's 9 over 2, and then doing it between 4 and 5, and I get minus 11 over 6. So yeah, I am right that 9 over 2 and the area there is 11 over 6, giving me an answer of 19 over 3. I'm quite confident that's the right answer for the total regions. Okay, and the last question, finally there. Okay, the value of a car in pounds V can be expressed as V equals 12,000 e to the minus 80, where A is positive constant. After 5 years, the value of the car is £4,500. So find the value of the car correct to 3 decimal places. So the value of the car is equal to £5,400 when t equals 5. So let's plug it into this formula. B equals 12,000 e to the minus 80. So 5,400 equals 12,000 e to the minus a times 5, 5a. So I can then say 5,400 over 12,000 equals e to the minus 5a. To undo this e, we're going to do the natural log. So it's going to be the natural log of 5,400 over 1,200. I keep saying 1,200, 12,000 equals minus 5a. So to get a, I'm going to divide this by minus 5. So it's minus 1/5 natural log 5,400 over 12,000. And we can plug this all on the calculator in one go. Minus 1 over 5 natural log of 5,400 divided by 12,000 is 0.159, 0.160, 0.160. So we've now got to use the formula, and we now know that the formula V equals 12,000 e to the minus 0.160 t. We want to find the value of the car after 10 years. V equals, so it's when t equals 10. 12,000 e to the minus 0.160 times 10. E to the minus 0.160 times 10 equals 2422.76. The value is £2,422.76. Using your answers to A and B to help sketch the graph of V against T. This is the formula. For starters, you know that it's a negative exponential. Okay, so that goes like this. But you're not going to have negative time. So this is going to be T. This is going to be V. So we have to start at T equals 0, and that's going to be 1,200. E to the power of 0 would be 12,000, sorry. 12,000. That's where we start, and then we go on a downward exponential curve like that. After 5 years, its value was 5,400, and after 10 years, its value was £2,422.76 there. Okay, and that's what the graph looks like. Okay, so help you. Y equals e to the power of x would look like that, crossing at 1. Y equals e to the minus x is a reflection in the x-axis, like that. That would be 1. But y equals 12,000 e to the minus x crosses there at 12,000. So it looks like that. Okay, hope you found this helpful. Okay, cheers, bye.